We're now on page 111, communicate questions. Number 1, what materials did you need to make a light bulb? Now, many of you would probably say a light bulb, 2 wires, and a battery, but actually you only need a light bulb, 1 wire, and a battery. You can actually take the light bulb and hold it against the one end of the battery, and then you use a wire from the other end to make contact with the light. Question number 2, go back to the illustrations on page 82 and 83. Choose one of the 4 pictures. Look at the picture again and make a new list to classify the electrical items according to the 5 transformations: heat, light, sound, motion, or magnetic energy. So that answer is going to depend on which one you selected. Question number 3. Explain how you think a light bulb goes on when it is connected to a battery. If you get stuck, reread Electricity on the Move. So there could be a little bit of variation again, but you should be include in your answer the notion of electricity flowing from one battery terminal through the circuit and back to the other battery terminal. Question number 4, I'm going to have a little video to help with this one. Hey, this is a supplemental video for question number 4 on page 111. Now, for that question, it shows you a bunch of examples of different ways of setting up your wiring for the light bulb. So I thought, instead of just saying yes or no, if it worked or not, I thought we could actually demonstrate it. So the first one we're going to do is on the top row on the far left. So it has 1 wire hooked up to the ground. As you can see, nothing works on that one. Okay, so for the middle left on top row, it's hooked up on the edge of the battery. Once again, that does not work. Okay, so for the next one, top row middle, it has the positive hooked up and the negative, and it's going to be hard to see on this video, but the negative is going to go at the base of the platform, so that one does not work. Okay, so let's go to the middle right, or sorry, I guess this would be the top right. Hooked up on the edge of the battery, no power. Okay, so now let's go to the bottom row, to the bottom left. That one works. So disconnect that one. Okay, so bottom, middle left. We have the ground and the, I'm just going to have to grab a different wire for this one. The ground or negative wire is connected at the same point as the positive. Now you can see the light isn't on, but we definitely would not want this left on very long, because the circuit would actually go from the battery to the negative and straight back to the battery. This can cause this battery to overheat and explode. Okay, so for the bottom row, middle right, we have the positive. I'm just going to hook the negative back up here, the way it was set up before. We have the negative hooked up, and then we have the positive set up by the base of the light. Okay, no luck. Okay, so now we're going to go to the bottom right-hand side. Okay, so we have the ground hooked up. The positive hooks up at the same point as the ground, and you guys probably couldn't see it, but I was actually getting some sparks there. Once again, the current going from the battery was going through the positive line, and it was making a circuit with the negative line. So all the energy was flowing from the positive to the negative straight back into the battery. So this would have caused it to overheat and potentially cause a fire. So it's vitally important that when you are doing your wiring, that you have things hooked up properly, or it's going to cause shorts, can cause wires to melt, and can cause fires in your house. That's why only trained professionals are allowed to do electrical work in homes.